Hey guys, welcome back. Houston Math Prep here. In this video, we're going to continue looking at finding inverse functions, if they exist. So remember, we have to first determine whether or not our function passes the horizontal line test. So taking a look at x cubed minus 4, we have a graph here which you can create using your knowledge of transformations or maybe using some technology. If we pass horizontal lines through our graph, no matter where we pass them, they only touch one time. So this one does pass the horizontal line test, meaning it is 1-to-1. So we do have an inverse, so we want to swap our inputs and outputs. Now remember, f of x is another way of expressing y values. So this is the same as y equals x cubed minus 4. So when we want to switch our x and y, then we'll have x equals y cubed minus 4. Now we have our inverse. All we need to do is solve it for y. So I'll start by adding 4 to both sides. So x plus 4 equals y cubed. To access the y and get rid of the cubed, I'm going to take the cube root of both sides. So I get the cube root of x plus 4 equals y. Another bit of notation, since our original function was called f of x, we can call this function f inverse of x. So our inverse function for x cubed minus 4 is the cube root of x plus 4. Checking out this next one, find the inverse of g of x equals 2 times the square root of x minus 1 if it exists. So again, taking a look at our graph for 2 times the square root of x minus 1, we have this graph here. If I test out a bunch of horizontal lines, no matter where I graph them, they never touch my graph more than once. So this one is 1-to-1. Now, in order to get my inverse, I'm once again going to need to recognize that g of x is like having y. So this is 2 times the square root of x minus 1. So first, swapping x and y, I have x equals 2 times the square root of y minus 1. Then I'm going to resolve for y. So the first thing that I'll do is divide both sides by 2. So x over 2 equals the square root of y minus 1. Now I'm going to square both sides to get rid of my square root. So I'll have x over 2 squared equals y minus 1. And lastly, I'll go ahead and add 1 to both sides. So x over 2 squared plus 1 is equal to y. Or using another bit of notation, since the original equation was g of x, we can use the notation g inverse of x to describe this. Now there actually is one other bit of information here. If we were to think about what the graph of x over 2 squared plus 1 would look like, that is a parabola with some transformations. Specifically, if I graphed that on the same set of axes here, that would look like a parabola that had been moved up 1 and was compressed. So that would look something like this. Now notice these two guys don't really match each other. This square root only has kind of 1/2 of the curve that this parabola does. So we need for these two functions to be inverses, which means both of them should pass the horizontal line test. So what we need to do is we need to place a domain restriction onto this parabola. We need to say, okay, well, this is the equation, but we need x to have limitations, or our domain to have limitations. So here, what we really want is we only want half of our parabola. So if we kind of imagine cutting off this half, we can achieve that by saying that x needs to be greater than or equal to 0. So we only want the positive half of the parabola so that when we switch x and y to create an inverse, we get this piece of our square root function. All right, guys, that does it for this video on finding inverse functions. Catch you in a future one.